it's already there. Okay. So hello everybody, my name is Marc Spizer. I'm working for Aquatiris, and so I'm going to talk to you about the use of constructed wetlands for individual wastewater treatment. So I'm stepping in for my colleague who couldn't be with us this morning. So I'm not a scientist. I'm gonna report her presentation as good as I can. Let's talk about first about Aquatiris, about us. We are a French company working mainly in France through a large network of franchise using reed beds in various designs and dimensions. So we are specialized mainly on rather small stations for individual houses. So here you can see some of our installations, some examples of typical installations that we've done the last years. So you can, as you see, it fits in the garden. We do actually about 2,500 installations a year, mainly in France. And we have done a total of 13,000 installations in the past 15 years. So here you can see some other products that we make, especially specifically for tiny houses, houseboats, or stormwater management. But like I said, our core business is focused on individual houses through the Jardins d'assainissement that I will present you now. So what's the Jardin d'assainissement? It's an adaptation, although reduced and simplified, of the famous French system developed since the late 70s by the CEMAGREF, presently the INRAE, which has been proven to be an effective technology with minimal maintenance requirement and low operational costs. I think most of you know how it works, so I won't go too much into details here. To make it short, we have two stages of vertical treatment. First stage is divided in 3 beds with a meter average deepness. The second stage is divided in 2 beds with the same deepness. It's designed for more than 20 person equivalents, so and it goes up to 2,000. So it's quite a large treatment plant. But we do, as I said, we do mainly treatment plants for individual houses. So our main challenge was to adapt this French system, which is relatively speaking quite big. It's originally meant for collective wastewater treatment in a small, autonomous and simple unit that almost everybody could use. Naturally, there were quite a few obstacles. First of all, there was the quality of the untreated wastewater. So as you can see in this INRAE study, the average inlet concentrations of the untreated wastewater are much higher in small treatment plants than in collective ones, about 2 times higher. This difference comes mainly from the type of flow coming in, which is much more diluted in collective plants due to higher water use by the users and also due to parasite water leaking in at various points. Like rain or other water, but for small stations they have a much lesser flow. That's due to careful users and extended rest periods during the day when the people aren't at home, and this leads to a higher concentration of organic pollutants. So it was quite difficult. We had some difficulties with that. Our second challenge concerns the regulatory framework, which differs between large and small stations in France. Collective stations have an obligation of results, so the design is adapted to the field and to the regulatory constraints. And but the smaller plants under 20 PE have an obligation of means. So the design and conception parameters are established following an extended approval procedure. In our case, it was 44 weeks on the test platform of the CSTB, which is a French organism, approval organism. And after this procedure, our system is considered as a product. So it wears an EC marking like a cell phone. And it testifies that the system is working well and fits the strong European standards. So after the water quality and the regulatory framework challenge, there were quite a few technical challenges. And mainly, the main question was how to adapt the design of the treatment plants to ensure high removal performances despite high inlet concentrations and strict discharge standards, take aesthetics quality into account, reduce the vertical footprints of the filter, and meet the regulatory requirements related to health protection measures. So let's see now how we've tried to solve all those various problems. So here you can see a little scheme of our Jardins d'assainissement. So as you see, like the French system, it's designed in two stages. First, a vertical filter of constructed wetlands, then a second, which is, unlike the French system, horizontal. Ideally, the whole system is conceived to work with gravity. So if the natural field allows it, it works without a pump. So here, for better understanding of the adaptations we have made, let's dive, if I might say, into the first stage vertical flow filter to see how it differs from the original French system. So first of all, as you can see, it is divided in two beds. You see it here. Instead of three. That makes it easier to handle for private persons and non-professionals. And it's made possible by the long periods of resting during the day. So when people aren't at home, the filter isn't always underwater, in water. So the arriving wastewater can be distributed on two beds only. You also can see that the beds are a little bit bigger than those in the French system. It's 2 square meters per person. That's because they are not as deep. They are only 60 centimeters deep instead of an average of 100 for the collective plants. And there's a thin layer of sand on top, which holds back most of the suspended solids. Important information on this picture is that the nominal organic load is more than 2 times lower than the French than in the French system, and same for the hydraulic load. It's due to the fact that we use sand for filtration, so we have to apply smaller loads to avoid clogging. So our first stage is a sort of combination of the 2 stages of the French system, because we are using sand on this first vertical filter. So let's now focus on the second stage, the horizontal filter. It's planted with semi-aquatic ornamental plants. So it adds an aesthetic value, looks nice in the garden. It's not deep. It doesn't return the whole garden when you install it. There is no visible water. The flow stays always at least 10 centimeters under the filter surface. So that's important for health issues. And the water retention time is higher than in the first stage. It's about a day. So let's talk about the performance efficiency of our first stage filter. So as you can see, the outlet concentrations already satisfies the French standards according to the CSTB measures. These measures were made during the 44 weeks of market authorization procedure. So we have also obtained a certification for a single-stage vertical flow plant, which we commercialize under the name Roseau. This one is the Iris line. And the second stage, as you can see, improves the clearing performances. Concentrations are more than 3 times lower than the required concentrations. This kind of filter is particularly adapted to treatment before discharge in sensitive areas like coastal zones with vulnerable ecosystems. It contributes also to denitrification and removal of pathogenic bacteria. Oh yes, then it's For individual wastewater treatment, we must also provide some protection measures to avoid contact with water and spreading of pathogens through animal action, for example. So there's a fence around both filter. There's also a horizontal grid on top of the filter, and there's a minimal distance from the house, which depends on the size of the treatment plant. So now that we've done with all the technical explanations, here's just a small focus on the life cycle assessment that we've carried out in 2019, and which was reviewed and approved by the INRAE. You can see it here. Main information here is that compared to classic systems used in France, working with the septic tanks and sand filters, our systems are generating 3 to 5 times less gas emissions during the treatment phase. There are no methane emissions because there is no fermentation process going on in the filter, and we don't use septic tanks. So, so it's the gray zone, as you can see, filtre sable on the right. The emissions during the working, the exploitation phase is much more consequent. In conclusion, we can say that it's been a long way to bring this extensive technology developed for large treatment plants into everybody's garden. As you can see, constructed wetlands can be an effective solution for individual treatment of wastewater. It's simple, it's efficient, and has very low operating costs, and has also a low environmental footprint. Well, thank you.